All right, so this is the fourth quarter curriculum check review. I'm making this video on Mother's Day, and so as a mother, I hope you guys really appreciate it. So I already went ahead and drew this because, I don't want to waste my time. It says you have a circle divided into 8 equal sectors. So those are 8, let's just pretend like they're equal. It doesn't look that good. I don't care though, because it's Mother's Day. So 8 equal sectors. That means these are all the same. And they should all add up to 360 degrees. So take 360 and divide it by 8, which is what, 45? Oh my heavens. My calculator says something weird. 360 divided by 8 is 45. So that means all these angles would have to be 45 degrees. And remember, when I make my videos at home, my pen is stupid. I tried to make it to where it was getting a good signal, but I wish you could see my setup. It's super janky. Okay, so in a rhombus A, B, C, D, let's get my shape recognition going. Yeah, just got rid of that extra part. So a rhombus means that all these sides are the same. Nope. Okay, so if you've got the letters A, B, C, D, it doesn't matter where you start. Like I could put A anywhere and B would be next. But you just have to, once you put it, you go in a circle. Like you can't do A and then jump across to B. So if I put like A here, B either has to be here or here. It has to go to the very next one. I'm going to go A, B. That's a good B. C, D. It's a really good B. Okay, so AB is 13. AC, that's going all the way across, is 24. And it says find the area. So area of a rhombus is 1/2 diagonal 1 times diagonal 2. Again, sorry about this stupid pen. So we have one diagonal, which we can call diagonal 1. It's 24. We just need the other one. Now, don't be confused. Rhombuses do not have equal diagonals. They're not congruent. So if I draw this in, it's obviously not as long as that one. Not that you could trust my drawing, but do you see how it's very possible that they're not the same? That's a good line. I don't care what you say. But I will redraw it because it actually was terrible. Now, if I draw in this other diagonal, I cut this into 12 and 12 because that's half of 24. I'm gonna have to move or something that's not working. So this makes a right triangle. So to get this other part of this diagonal, we just do Pythagorean theorem. So I'm gonna call this X, just so it makes sense with our picture. And I'm gonna try to move and make this a little bit better. But then I won't be able to see my computer. Okay. So x squared plus 12 squared equals 13 squared. So that's x squared plus 144 equals 169. I'm going to get x squared equals 25 after I subtract the 144 from both sides. So x equals 5 when you take the square root, which means that this part's 5 and this part's 5, making the entire diagonal 10. Now, a lot of people get confused here. Sorry if I was yelling. I was right up on the microphone when I just said that. You don't do 1/2 times 24 and get 12 and 1/2 of 5, or 1/2 of 10 and get 5. Just go in order. 1/2 of 24 is 12 times 10. You don't distribute that 1/2. It's because we're not adding here, we're multiplying. So 120. All right. Good Bobcats. Okay. The figure below is made up of 2 squares. A square by definition has 2 equal sides, or all 4, but the 2 that you're using for length and width are equal. So that means that whatever this is, since the whole thing's called X, I'm going to call this Y. If that's y, this is also y. If this is the area, that means y times y, or y squared, equals 576. So to get what each of these sides are, you'll just take the square root. Square root of 576, I believe, is 24. It's a good equal sign. And we'll call this z and z. So z squared equals 1024. So to get just z, we got to take the square root. I think that's 32, but at this point I'm really just guessing, so I should probably check some math. Oh, not squared, not squared. Equals. Okay, so let me just check. 24 squared is 576, so that part was right. 32 squared is 1024, so I was right. So that means this part is 24, this part is 32. So what, that's really hard to see, 24 and 32. So to get the entire x, we just add them together. 32 plus 24 is 56. So x equals 56. Ishy-pishy. That's a terrible circle. Not even a circle, more of an ellipse. That's a good one. It meets right over here. Find the area of the kite shown. So much like the rhombus, area is the same formula, 1/2 diagonal 1 times diagonal 2. And we're going to have to use Pythagorean theorem, maybe, yeah. We'll have to use Pythagorean theorem. So if this part's 6 on a kite, one of the diagonals is bisected. So this one is bisected, so these are both 6. It's obviously not this one that's bisected because those don't even look the same. So when we're doing 1/2 diagonal 1 times diagonal 2, we've got one diagonal is 12, and we don't know the other diagonal. However, this 12 did not come from here. It came from this diagonal. 6 plus 6 is 12. So to get this diagonal, we're going to do 12 plus whatever we get for this part. To get this part, we have to do Pythagorean theorem. So let me switch colors. That's going to be 6 squared plus x squared equals 10 squared. So if I subtract 36, I get x squared equals 64. So x equals 8 after you take the square root. I really, really hate this. Like, it works perfectly at school, and then it's like I get home and it's like, haha, I'm gonna be rude. All right, so that's 8. So 12 plus 8 is 20. So 1/2, I'm gonna do 1/2 times 20 and get 10, and then do 10 times 12 and get 120. Wow, it's a lot like that other one because they're both 120. Okay. This one looks hard. In the figure below, a circle has a radius of, it says 8, but the picture says 9. My guess is that we're supposed to do 9 right here. And I would also guess that the test was 8, and I didn't change the wording, I just changed the picture. That would be my guess. So in the figure below, a circle has a radius of 9 feet. The area, or find the area of the shaded region and round to the nearest tenth. So the shaded region is going to be the circle area minus the square. So circle is pi r squared. And for the square, since we're given half of a diagonal, I'm going to use 1/2 diagonal 1 times diagonal 2. So pi 9 squared makes 81 pi. Then 1/2 diagonal 1, if this is 9, the whole thing is 18, and you have congruent diagonals, so 18 and 18. So half of 324, 162. So that squares 162. So in your calculator, you would type 81 pi minus 162 because it says nearest tenth. So 81 pi minus 162. and I got 92 point, let's say near 10th. Sorry, I had to get far from it to make the pen work, and now I can't read it. 0.5. Now, it says, using the picture for this one, what is the probability that a randomly selected point is inside of the shaded region? So probability means we do shaded, which is this, over the total. And then we do times 100. Now, we don't want to use the rounded one, so I'm going to use this since this is still exact. I'm going to put that for my shaded area on top. Now, the total is basically the shape that is the whole thing, which is the circle. So that means on bottom we get 81 pi. Now, you're either going to need to put that in parentheses and this in parentheses, or do the alpha y equals. Let's see if my calculator's open. I don't know if it is, but it will open for me. And then we'll do times 100. That's a good 100. Okay, so if you have an older calculator, you're just going to need to do it. I would honestly just do it in separate steps. Like do 81 pi minus 162 and then hit divided by 81. Then I'd hit divided by pi. I'll do it both ways. You know, I've got all the time in the world. It's not like it's Mother's Day. So I would do this. 81 minus 162 if you don't have a newer calculator. And I would type the 6 instead of just the 2 because that'd be cool. And I'd hit enter. And I get this, what we just had. Then I'd divide by 81. Hit enter. Don't put the pi there because then it multiplies by pi. Then divide by pi. And then we're going to multiply by 100. Now I know you can't see the big screen, but I want you to see what buttons I'm clicking. I don't know why I care. And I can't fit it all on there. So you can see it right here. So 36.3 is the answer. I'm going to go write that here. 30. Nah, that's bad 3. I'm not going to lie. And your curriculum check is multiple choice, so that's nice. But I think the best way to do it for real, if you have a good calculator or a new calculator, is to go not math. Let's just clear out of that. Let's go alpha y equals and then enter. Then on top we can put 81 pi minus 162. And then on the bottom we can put the whole 81 pi. Then out to the side we put times 100. 36.3. You get the same answer. You just don't have to worry about separate steps and all that. All right. What is the area of circle T? So area of a circle is going to be pi, let's see, area is pi r squared. Sorry, my pen's not working so much that it makes me mad. But we need the radius to get that. So the whole point is that first we're going to have to get the radius, which this is one of those Pythagorean theorem problems where you have to FOIL and, you know, it's crazy. So here's a leg and here's a leg. So we've got r squared plus 24r, this is Pythagorean theorem, equals the hypotenuse squared. Well, the hypotenuse is r plus 16, because that 16 just goes to the outside. Then we got to square it, which, if you remember correctly, that is like doing r plus 16 times r plus 16, and you've got to FOIL it. Getting real frustrated with this. Okay, so r to r is r squared. R to 16 is 16r. Now I gotta change colors for dramatic effect, if it will let me, because it hates me and it thinks I'm dumb, and I don't know why. I've always been nice to this pen-ish, you know. Now we do 16 times r, which is 16r. 16 times 16, which is 256. Then we combine it, we get r squared plus, this makes 32r, plus 256. And the shortcut I taught you is that you just square the first number to get the first one. Square this one to get the last one, that's 256. But to get that middle term, you're going to multiply these two together, that's 16r, and then double it, and that's 32r. But if you can't remember that, just, you know, square it all. R squared equals, is this a 24? That looks like a 34. So 24 squared is 576. Okay, so I'm going to subtract the r squareds. They'll cancel very nicely. Then I'm going to subtract 256 from both sides. So the 6's make nothing. That makes 2 and that makes 3. So we get 32 equals 32r. And if that's the case, then you divide by 32 and r equals 1. And if r equals 1, the area is pi 1 squared, which gives you, well, either 1 pi, which I think is on the test, I think it's in terms of pi, or that's going to be 3.14, or it might be 3.1 if it wants you to round it to the nearest tenth. This one didn't say. I'm pretty sure the test it's exact, so the pi's in the answer. And remember that squared, the only reason it's still the same is because 1 squared is 1. If this was 4, right here, then you'd do 4 squared, which is 16, and the answer would be 16 pi, because it is area. All right, so we've got two lines intersecting inside of a circle, but not in the center. We're looking for segment lengths, so that's part times part equals part times part. So 8x equals 16 times 9. Is that, wow, 144. I was way off in my head. I didn't say it. Okay, so 8x equals 144. Then you'll divide that by 8 and get x equals 18. This one's the one that's a little bit tricky. It's outside part times whole thing. So outside part is 10. Whole thing on this bottom one is 27. That's not really the tricky part. It's this next part where the outside part is 9 and the whole thing is x plus 9, or 9 plus x, either way. So 27 times 10 is 270. You got to distribute this 9 to both of these. And you get 9x plus 81. So then we'll subtract 81 from both sides. So 270 minus 81 is 189 equals 9x. And x is 21. Okay, so the center and radius of each. So the center and radius. So if you remember, these are supposed to be negatives. So if it's negative, then it's like you change the sign essentially. So that's negative 13, so then make it positive. -3, make that +3. That's the center. Radius is this, or well, this is r squared, the radius squared. So you got to take the square root. So if we're talking square root of 12, oh my heavens, you can't round that to a decimal. You got to break that down and bring out some pairs. So that's 4 and 3, 2 and 2. So we can bring out a pair of 2's. So 2 radical 3. That's our radius. Here, our center is 7, 3. Now, if either one of these were positive, it would be negative here, but they're not on either problem. The radius is the square root of 4, which is just, it's supposed to be equals 2. All right, find the area of the regular polygon. So that's 1/2 perimeter times apothem. So perimeter would be 16 times 5, which is 80. And I've got that because there are 5 sides. You just count them. So 1/2. Sorry, I'm struggling with the pen. I know I complain about it a lot, but it's like a constant problem I'm having. And then the apothem is at 11 over there. That goes to the side. So half of 80 is 40, and then 40 times 11 is 440. Now, I've said this many a times, but on a hexagon, the apothem's always half of a side, which is 12, times radical 3. But I'm going to show you how to get that in case you can't remember it. So this angle right here is a 30-degree angle. This is half of a side. So if a whole side's 12, half a side is 6. Since it's a 30, 60, 90, you just multiply that by radical 3 to get here. So it's 6 radical 3. So 1/2 perimeter times apothem. Perimeter is 12 times 6. So 12 times 6 is 72. So 1/2 72 times 6 radical 3. So I would do, a lot of people do different things. Just don't type in the radical 3. If you're going to do 72 times 6, that's fine, and then divide that by 2, you get 216. I would probably do half of 72 and get 36, and then do 36 times 6, but it doesn't matter. Like, you'll come out with the same answer. Oh my heavens. All right. Area of, well, first of all, you've got to know what shape this is. And, no, I think that, it's a trapezoid. I was thinking that was on the review, but I think that was the final exam review I was looking at. So a trapezoid is 1/2 base 1 plus base 2 times the height. So the bases are the ones that are parallel to each other, and the height is perpendicular to the two bases. So we're talking, our bases are 9.9 and 3.3. And you add those, and then you multiply the height, which is 8. So 9.9 plus 3.3 is 13.2. So we're doing 1/2. 13.2 times 8. And we get 52.8. Okay. Find the length of each arc and area of each sector. So the difference in arc length and area of a sector is just that bottom formula. So this one right here, if we're looking for the length in the area, the x is going to be up here on both of them. And this is going to be the degree of the arc or sector out of 360. So for length, and it says this on your formula chart, it's circumference down here, which is 2 pi times the radius. And I'm going to switch to blue. If we're doing area of a sector, it's pi r squared that's down here, so pi 8 squared. Now I do believe these answers are left in terms of pi. Nope. So we're not going to type the pi in our calculator, we're going to leave it in our answer. So here I would start by doing 8 times 2, which is 16, times 45. So 16 times 45 is 720. So when I cross multiply this, I get 720 pi. And that equals, cross multiply this, that's 360x. So then to get x by itself, we divide both sides by the 360. And 720 divided by 360 is 2. So you get 2 pi equals x for arc length. I'll show you this divided by 360, divided by 360. Then when we do this, we do 8 squared, which is 64 times 45. So 64 times 45, that's 2,880 equals 360x. Oh, I forgot my pi. And then we'll divide both sides by 360. And you get 8 pi. And remember, if you get a decimal, you put it back into a fraction. Your actual test is multiple choice, so it won't be a problem, but hopefully you can figure it out. You just do math, enter. Okay, so doing length over here, we do 315. And I'm not going to have as much room, so I'm probably not going to write this step. I'm probably just going to talk you through it. And that equals x over 2 pi times the radius, which is 18. So I'm going to do 18 times 2 and get 36, and then multiply that by 315. Okay, maybe I will have room. Let's see. And then we get 360x, and then we divide that by 360. And see, I got 31.5. And you can't put a decimal like that in front of pi. So I'm going to hit math, enter. And I get 63 over 2. So 63 pi over 2 equals x. And that's for length. Then for area, I'm going to do 315 over 360. Nope, I tried. Equals x over pi and then 18 squared. I'm really not going to write all this one because my pen is making me mad. So 18 squared. Oh, I messed up. 18 squared. Sorry, I typed it wrong. 18 squared. 324 times 315. And that equals, and that with pi equals 360x, divide by 360, and you get 283.5. We hit math, enter, and get 567 over 2, and the pi goes on top. That's for area. All right. How many more of these do we have left? Oh my word. I'm so mad at this pen already. All right, so surface area of a cylinder. Let's hope I can remember this because I don't have my formula chart. I do believe that it is 2 pi RH plus 2 pi r squared. For a pyramid, I believe it is 1/2 perimeter times slant height plus area of the base. And I say that real nicely because I'm a teacher and I know what to say. So I don't say PL. I say perimeter times slant height and area of the base. But you have to know those things in your head. On test day, I will not tell you what things stand for. You have to know that going into a test. That's part of learning. So 2 pi, r is 12, h is 9, plus 2 pi 12 squared. So I'm just gonna, you can type that whole thing in without the pi and it should just be perfect, but I'm gonna do one step at a time. So 2 times 12 times 9 is 216 pi for this first section. Then 144 times 2 is 288 pi. And then add 288 plus 216 and you get 504 pi. All right, on this one, P is perimeter of the base. So the base is the rectangle. So it's 10, 10, 10, 10. That makes the perimeter 40. The slant height is 13. Plus capital B is area of the base, which is length times width for a square, or base times height, which is 100. So I'm just going to type that whole thing in my calculator. And I get 360. That was a good circle. Nope. One of these days, man. One of these days. Forget that last little line. It's stupid. Okay. Well, let's see. Volume. I believe this one is 4/3 pi r cubed. A lot of people forget that cubed. But we're given the diameter here is 18. Yeah, 18. Which makes the radius half of that. The radius would be 9. So 4/3 pi 9 cubed. So what I would do first is do 9 cubed, which is 729. And then multiply that by 4/3. What I do is multiply by 4, then divide by 3. And I get 972 pi. Volume of a prism is just capital B, which is area of the base, times the height, which is the distance between the bases. So capital B, area of the base. The base is a hexagon, so that would be 1/2 perimeter times apothem. So the entire formula is half pi, because I'm bringing down this h. So perimeter of the base is going to be 7 times 6, so that's 42. The apothem is given to us up there. I believe it's 6.1, hopefully. It's too small for me to see. And then the height is 12. Again, I'm going to type that whole thing in. And I get 1,537.2. Oh, these are easy. Name the figure. So this is 2 triangles and 3 rectangles. So it's mostly rectangles, which means it's a prism. Because if it was a pyramid, it is neither of those. This one, it's mostly triangles and one shape that's not a triangle. So the shapes that aren't rectangles, those are the triangles, tell us it is a triangular prism. This one is mostly rectangles, and then it has two trapezoids, so that is a trapezoidal prism. Last two, right? All right, so this is angles and arcs because they're in degrees. So if you were looking at the circle notes paper, it would be the column in the middle. These are intersecting inside the circle, but not the center. So that is the one where you add the two arcs together and divide by 2. So one, and I'd be careful about that because if you don't, like I'd add them first, like add 153 and 55 so I don't have to worry about parentheses. Get 208, then divide it by 2 so that I get 104. 153 plus 55. Just making sure I did that right. Okay, then this one, this is where you subtract them and it's half the arc, but first we've got to actually figure out what this is. So if the whole thing is 360, to get this part we don't know, we just subtract the 110 and get 250 for this one, for the big arc, and then subtract. So 250 minus 110 divided by 2 equals the angle, which is 7x minus 7. So I'd actually do 250 minus 110 and get, what's that, 140? And then divide that by 2 and get 70. And that equals the 7x minus 7. Add the 7, you get 77 equals 7x. And x equals 11 when you divide. Bad circle again. My bad.